All right, so this is the lab on page number 10 and 11, How Dry Am I? And that's not just about my sense of humor. You can laugh. Okay, thank you. All right, so like I know I did this for you guys yesterday, but this is for fifth hour since you never see me. Yes, you never see me. All right, we're going to put water in cans, label products and reactants. Did I point to that the right way? You will use the appropriate size beakers. So in this lab we have a 250, the big beaker, and the 150, that's the small. Small goes into the, yeah, it's not that hard to figure out. All right, so we're going to pour water back and forth until we reach an equilibrium. So I'm just there in that top paragraph. An equilibrium is reached when there is no change in the height of water in either can for at least 5 consecutive water transfers. I asked you guys yesterday, so hopefully you remember. Does that mean the height in the water or in the can is equal? No, it doesn't. It means that the heights, they can be unequal, but they won't change for 5 total pours from left to right and right to left. You with me? Okay, so in here where you take your data, you have your trial numbers 0 through 20. You will need the numbers to repeat themselves 5 total times. But once again, it's not going to get the audio, but once again, are they the same number 5 in a row? The top and bottom aren't going to be like 8 and 8, 8 and 8, 8 and 8. It'll be like 10 and 5, 10 and 5. You with me? Okay, now, let's continue to read on. So record the height of water in each can in the data tables. Follow the information given in the table to find out what to do. Then in all caps, you notice it says, do not tip the cans when filling the beakers. Only take what you can get. So when it gets low, you can't pick this up and pour it in there. That's what it means by don't tip it. When it gets low, you just fill it up as much as you can get. Does that make sense? Okay. So you can tip this, because it's called a beaker. You can tip that all you want. You can't tip this because it says don't tip the can. All right. Then it says graph your results. Did I talk about the graph yesterday? It would be 2 separate lines. Okay, good. I better move my little friend here. Let's go on a little adventure here. All right. We don't want Dutson's side of his head in the video the whole time. Although it's a great looking side of a head. What is this, speaking of great looking heads? All right. So what you're going to do when you graph this data, ooh, that's some nasty stuff right there. So you will have, oh great. You're going to have trial number on the bottom, and write this on the graph right now. So the trial number will be on the bottom of your graph. Of all 3 of them, they're all going to be the same type of graph. Just chuck it. All right. Then you're going to graph 2 lines, and do them in 2 different colors or 2 different styles. But so I have a green marker. We'll say the green represents the height of reactants, and it would start high and kind of end low. You with me? Now don't draw your line. It'll look different than that. And then you have a separate one where you graph a different, and the blue marker is kind of dying. But now that would be the height of your products, and that would start low and go high. You all right with that? So on all 3 graphs, you'll have something like this. Now, some of them cross. Some of them won't. That can't really happen if you have 3. All right, that's how your graphs are going to look. 2 of them will be the almost exact same, and 1 will be the opposite of that. Who's with me right now? Like that graph? Are you okay with that? Okay, so the stuff you're going to graph, once again, would be the height of the water cans. So if you look at part A, it says start with more water in the reactants can. So I've already done that. I've poured more water. I would start about 10 centimeters. If I say any number today, I mean it in centimeters, not inches. You okay with that? So 10 centimeters-ish. It's up to you. But don't go too high or too low or it won't work. And if you go too high, you'll just eventually overflow one side, and that's not the point. So it says to start with more here and here. And then it says use the 250 beaker for the forward reaction. That means from reactants to products. Do I have that right? Does that say reactants? All right. So I record my initial height, then I fill this one up, pour it over, and then I get the smaller one for the reverse, fill it up, pour it over, and then I remeasure both heights in centimeters. And I do that again, big that way, little that way, measure again, and I stop when the numbers don't change for 5 times in a row. You okay with that? Okay, when you get done with number 1 or part A, if you start number 2, because like when you finish number 1, it's going to meet the requirements for part B, like you will already have more water in the products can than the reactants can. If you just start part B with how part A ended, it's already done. So adjust the water again, or you'll just do the exact same thing for 5 water transfers, and you'll think, well, that was stupid. And it was. Okay, adjust your water, and you should be fine. Okay, what we're going for is the concept of equilibrium, which means what, Bragger?
Reactants go to products, the same rate as products break down to reactants.
Perfect. So it means our reactants go towards products at the same rate our products are going to reactants. Perfect definition of equilibrium. This lab, usually about 80% of kids are like, this will never work. That's a bigger beaker going that way, and that's a smaller beaker. But by the end, 100% of you usually understand it, and you really, really grasp what equilibrium is. When you reach equilibrium today in this hour, yell it out, and I will come and I will check to see if you're at equilibrium, and we'll show you exactly what it is. Got it? Okay, you're going to have tons of water everywhere. Wipe it up when you're done. You're fantastic humans. Thank you.